right, so we started yesterday with verifying trig equations. So instead of an expression as before Christmas, simplifying it basically open-ended, we're dealing with equations. You would choose one side of the equation, the left or the right, and using the identities, algebra techniques, and so forth, you're going to go ahead and try to make the chosen side look like the other side. So we'll get back to that in just a moment. Just a few housekeeping items. What is happening tomorrow? Okay, you got your quiz. So there's 5 questions, okay, and it's going to be over simplifying these expressions. Now, you won't be given equations. You're just going to be given something like that, and then you'll be asked to simplify it. Okay, so 4 out of the 5 is going to have you do that. The first problem is just a throwback review all the way back to when we first started learning trigonometry. I'm going to give you a trig ratio and ask you to find another one based on that. So I'm hoping it's not going to be too bad. Now, somebody in first period did ask me if there were any additional problems that they could use to practice. So I did do a quick search. So if I go to our Google Classroom, okay, so if you go in the current week, the 8th to the 11th, right here at the bottom, simplifying trig expressions with the key. So you've got 20 different expressions, but what's nice about this is that it does go ahead and kind of walk you through the process on all these. Okay, and it goes ahead and gives you little icons here to kind of get you to see certain things when you use substitution or something like that. But if you are looking for a little more practice, and who wouldn't be, because it's fun, right? It is really quiet in here, okay. But this is available to you if you want to take a look at that. Okay, if you're having trouble with some of those, you know, I'm going to be here in the morning. Just come on in. That is the Eurythmics. We don't need to worry about that. Okay. It is a good song. I just had it, you know, on autoplay, and that's where it stopped earlier. So there you go. Okay, so besides the quiz, in a couple of weeks, we have the test coming up on the 24th. I'm hoping to get that started today. Definitely by tomorrow. I want to try and get that written as soon as possible so I can start talking to you guys about it. But, you know, Friday, I'm hoping to just move on with the next lesson. Tomorrow, we should be done with everything by today so that tomorrow we come in, we go ahead, take our happy minutes, we'll go ahead and take the quiz at the beginning of class, and then whatever time is left, I'll just go ahead and let you work on the assignment. All right, so any questions about what's going to be happening? Okay, well, let's get to it. The strategies that I was mentioning just a few moments ago, they are listed right here on the front of your packet that you got yesterday. So the trig identities are probably a great way to start. One of our best options is always to rewrite everything in terms of sine and cosine. That's always a great strategy, unless it's already in terms of sine and cosine. Algebraically, add fractions, factor, distribute, conjugates is always a good one. And at the end, because we're now proving these equations, we're starting to put QED, which we have the Latin here, but we're just going to go ahead and say quite enough done. And I'm pretty sure, did we get through number 4 yesterday? Was that our last one? Okay, so we were about to start 5. Okay, good. All right, well, I'm going to go ahead and work a couple of these with you, but I'd like to get some more folks up here today to show me the rest of these. So let's just get right back into examples and see what you think. Number 5, sine squared of theta times cosine of theta times secant of theta equals 1 minus cosine squared of theta. Okay, which side do you think is the more complicated? Okay, the left, okay. We can go ahead and absolutely start with the left. Now, the thing is, we want to start with the larger or the more complicated side because we want some more options, whether it's using the identities or doing something algebraically to try and make the one side look like the other. So my goal is to make sine squared times cosine times secant look like 1 minus cosine squared. Well, bless you. Does anybody notice anything just right away? Okay. What about the secant? There you go. That's exactly right. Okay, if one tells me we have cosine, there you go, because they are reciprocals. Yeah, secant says 1 over cosine of theta. Yeah, since those guys cancel, basically that's just 1. So what's sine squared times 1? It's just sine squared, right? So how can I make a sine squared look like 1 minus cosine squared? There's a Pythagorean identity. In fact, hopefully it's the first one you listed on your happy means. Sine squared of theta plus cosine squared of theta is equal to 1. So if I'm looking for 1 minus cosine squared, well, I'm just going to go ahead and subtract that over. Minus the cosine squared. Okay. So when those cancel, this is what we want, and we see that that is equivalent to sine squared. Okay, so that's it. See, the difference here, it's not really the last statement that's your answer, it's getting there. We already know where it is we're trying to get to. We already knew that my last statement should be 1 minus cosine squared. Okay, it's the process getting there that we're really interested in. And this one here didn't take but a few steps, and sometimes, you know, that's going to happen. It might happen pretty fast, 1 or 2 steps, and you already have the other side. There might be some problems where it's like previous one, number 4, where it might take multiple steps in order to get to where you need to be. All right, any questions? Okay, well, let's try number 6. The extra terms in the denominator on the left expression makes it more complicated. Now this one, actually, you could go ahead and work it either way. You could work the right or the left. It does go ahead and hint the left, so why don't we go ahead and start there. Cosine of t over 1 minus sine of t. So I'm taking this expression, and I want to end up with this. I want to end up with 1 plus sine of t over cosine of t. All right, so I'm looking for anything that can help me. And maybe if we went back to the original list, okay, is anything kind of jumping out at you that we could use? There's one thing I'm kind of thinking of. We have a single fraction, but the denominator is a binomial. Who said it? Who said conjugate? Xavier said conjugate? Perfect. That is exactly how I would do it. Xavier, what's a conjugate? So part of it's going to be the opposite, so you're on the right track. The first terms are going to be the same. It's the second terms that are opposites, right? So if I come on back over here, if I have 1 minus sine of t, what's its conjugate? 1 plus sine of t. There we go. So 1 plus sine of t. And I got to multiply both parts by it. Okay. Because what is anything divided by itself? This is really 1, right? Okay. And what happens when I multiply anything by 1? Yeah, it stays the same. So it's true, we're trying to manipulate the way the expression looks, but I don't want to change his value. I want his value to remain the same. So that's why we're doing it in this way. Okay, now here you have to make a decision. And we actually talked about this earlier, way before the break. There are going to be times where it's better to multiply, and there's going to be times where it's better to just leave it as a product. Okay, this is one of those times. When I go ahead and multiply, what do you think? Should I go ahead and take the cosine and distribute it, or should I go ahead and just leave it as a product? So this time you want me to leave it. Okay. So I'm going to multiply across, so this would be cosine of t times 1 plus sine of t all over. Now I would recommend multiplying those conjugates together. Can anybody tell me what would I get? 1 minus sine squared. There we go. In fact, does anybody want me to go ahead and FOIL the two groups together to kind of walk you through and show you how I got that? Everybody's okay. Okay. Well, now what? There we go. Okay, because what identity did you use, Xavier? Pythagorean identity. He says 1 minus sine squared is cosine squared. Just imagine this identity subtracting the sine squared instead of we did previously the cosine squared. All right, so this is cosine of t times 1 plus sine of t all over. So 1 minus sine squared is cosine squared. Now what? What does that allow me to do? Okay, we can cancel here because we're multiplying. So 1 cosine cancels there. And actually, what do you notice? There it is. That's exactly what we wanted. We wanted 1 plus sine of t over cosine of t. There we go. So QED. Quite enough done. Okay. So this is the second day. Is it starting to come back? We kind of start getting back into it, remembering all these identities? Okay. Does anybody have a question about anything we did? No? Okay. Well, let's go ahead and start looking at some of these with some help of people in the audience. 1 minus sine squared over 1 plus cosine equals cosine. Okay. Now on this one, probably what side would I begin with? I would say let's begin with the left side. There's a lot more going on there. Okay, so I've actually seen some really nice ways of manipulating this one today. I know what I would do, but I'm interested in getting somebody up here who can show me what they would do. Do I have any volunteers? Okay, so many hands going up, I can't decide. So I'm going to go ahead and use my random number generator. So let's see, this class is almost full, so I'll go ahead and say, I think the last one we have is 34. Dylan, that's right? Okay. All right, so probability, random, integer. Okay, so we want 1 out of 34. Okay, so any volunteers before I go ahead and push enter? Christian, you want to do it?
I don't know, man. It's like it seems easy because you could just like split it up and just make sine squared and then just 1 over cosine. No, it would be. Oh, it would be. I would have been wrong. It would have been TJ.
Okay. So you just want me to roll the dice and
Yeah.
maybe it'll be number 3. I don't know. 14. All right, Skylar. That's okay. That's all right. We're going to help you out, or whoever wants to come up. I like his answer. I'll help you once you get there. All right, so Skylar, what are you going to do?
Use the conjugate for the denominator on like multiply 1 minus cosine. So the top and bottom. I think I'm gonna multiply.
Okay. Now you could, that might ultimately end up giving you a little more work because it's not just a single fraction. You'll notice it's 1 minus that. So then you would still have to worry about the 1. Now don't get me wrong, that would still work, but I'm just thinking that might give us a little more to do. So you go ahead and do that if you like. That is a good idea.
I'm thinking about splitting it up, but I don't know if that would work.
Well, you can't split it into 1 minus sine squared of x.
No, I'm saying sine squared.
Now, well, it's already split up. Because it is split, you could combine them into a single fraction. Okay. Or I'll go ahead and tell you another method that some people are doing on this. Instead of taking the 1 and the fraction and combining it into a single fraction, some people are immediately changing sine squared using an identity. So actually, there's a lot of good methods here. Skylar, what do you like best? Okay. Oh, there we go. So if I were to change sine squared, what would that be? 1 minus Cosine squared, because it's a Pythagorean identity, right? Okay, so let's start there. Okay, now remember, our goal is to just get it down to cosine. Okay. So actually, I didn't see this until last period, because my first idea was to go ahead and just combine them using a common denominator, because I always like to do that. But why did these folks say 1 minus cosine squared now? Why does that help me? Now, we can't cancel anything yet. Okay, 1 minus cosine squared, what type of binomial is that? That is a difference of squares, yes. So I can split it up into, what do we call those groups? Conjugates. Okay, so Skylar, are you following? Okay, so let's say 1 minus. Okay. Now go ahead and draw your division side. I forget what that's called. I'll look it up. But 1 minus cosine squared, what would the factored conjugates be of that? Okay. So 1 plus cosine x. And let's go ahead and put that in parentheses, since we're going to have another one right next to it. Oh, the 1 minus cosine x. That's okay. That's okay. And now another parentheses. And then 1 plus. There you go. Mm-hmm. Because if I multiply conjugates, I get a difference of squares. We factored a difference of squares, and now we have conjugates. And that's all over 1 plus cosine of x. Now, why is that good? You can now cancel. There you go. Well, now, we couldn't cancel in the previous step.
Oh no, but like if you just do it in your head.
Okay, if you do it mentally, okay, I see what you're saying now. Now, will 1 minus that binomial give me cosine? So let's see. Now, you'll notice the 1 minus cosine is in parentheses, so what am I going to have to do? As soon as I subtract it, I'm going to have to distribute. There you go. Mm-hmm. So that would be 1 minus 1 plus cosine of x. There you go. Then the ones will cancel. Cosine equals cosine. And we have shown the left equals the right. They really do. They really do when you have your own kids. Oh, forgetting one thing. QED. Oh, no, this won't be on the quiz. Remember, the equations are not on the quiz, just simplifying expressions. Okay. So, yeah, I'm not looking for QED on the quiz. No. Okay. All right, good. Good job. Okay. Any questions? Okay. Now, like I said, that was a great method that someone in second period did. My first idea was to go ahead and combine them using a common denominator. So instead of this 1 right here, I put 1 plus cosine of x over 1 plus cosine of x, and then minus the second fraction, sine squared over the 1 plus cosine of x. That's how I started the problem. I just got a common denominator. Okay. Did anybody want to see this to the end? You do want to see it? Okay. Because I'm thinking maybe that's what's going to help a lot of people out, because are there different ways to solve these same problems? There's always going to be different ways, and that's maybe where some of the difficulty could be. Well, let's go ahead and combine those. So this would all be over the 1 plus cosine of x. So I have 1 plus cosine of x minus the sine squared. Okay, now here's what I did. You'll notice I can use an identity in the numerator. Which one do you think I'm looking at? The sine squared lets me use Pythagorean. Now, you can either replace sine squared with 1 minus cosine squared, but see, we have 1 minus sine squared right here. So it doesn't matter that they're separated by another term. 1 minus sine squared, that is cosine squared. Okay. So I have cosine of x plus cosine squared of x all over 1 plus cosine of x. Now what did I do? Okay, you can factor a cosine out of the top. So cosine of x, that would leave me 1 plus cosine of x, which is still over 1 plus cosine of x. And I can do what? Cancel those groups and say I still ended up with cosine. In fact, someone in first period did something very similar. Instead of using this 1 here when they used the Pythagorean identity, they just replaced sine squared itself with 1 minus cosine squared. And see, distributing the negative is still going to have the same effect. The 1s are going to cancel, and you're left with cosine squared. Okay. How we doing?
Wait, so
Yes.
that one is like universal then? Since you just put it like.
Well, the Pythagorean identity that I used includes 1.
Okay.
So I originally decided to use the 1 with the sine squared, but even if I hadn't, the minus 1, see, those ultimately still would have canceled.
Oh, okay, I see.
Okay. All right. Okay, so I know what you're thinking. I'm ready for 1 on our own, right? Okay, so here's this one. Cosecant of theta minus sine of theta equals cotangent of theta cosine of theta. Let me give you 4 minutes. Okay. Perfect opportunity to go ahead if you're stuck. If you have a question, you can definitely ask me or get to know your new villain buddies. Okay, look around, see what villains have the same colored cards. Okay, you can definitely bounce ideas off each other. And you can choose, this one actually either works both ways. You can go from the left to the right or the right to the left. Okay, whatever preference you have. But at the end of 4 minutes, I'll use the number generator. We'll get somebody up here. Help me out with this one. We still got 2 minutes. Plenty of time. Is there anybody who thinks they've already completed it? Okay, so a few folks, okay. 20 seconds. Okay, so you may or may not be done, and that's okay. Let's see here. Do I have any volunteers? Okay. All right. Dylan, come on up. Let's see who would have been chosen. 25. Who is that? I think that's over there. It was Satish, okay. All right. So, Dylan, did you choose the left or the right side?
I chose the left side.
Okay. So let's see what you did.
I changed cosecant, so 1 over sine theta minus sine theta over 1.
Okay.
And then I multiply this side by sine of theta over sine of theta. And that gives me 1 minus sine squared of theta over sine of theta.
Perfect.
And then change 1 minus sine squared to cosine squared
Okay. So again, the same Pythagorean identity.
over sine theta. And then I just split up the cosines into cosine of theta times cosine of theta. Wait, can you do this?
Oh, absolutely.
Okay.
Mm-hmm.
Over sine theta.
Yeah, because that'd still be the same. It's just cosine over 1 times that fraction. Okay.
That's cosine of theta times cosine.
There you go. That's perfect. Okay. Any questions on what he did? How many other people were able to get to the other side? Oh, got a lot of hands going up. Is there something I can do to help? No? Okay. Just a wrong identity?
Yeah.
Okay. All right. Yes. You want to work the right side? Yeah, let's do the right side. Okay. Did anybody who chose the right side? Okay. So, Rhett, you're the first person I saw who raised your hand. Okay, so cotangent cosine. Okay. Oh, I was just going to ask you what you did, but yeah, come on up. There you go. Perfect. Okay, so Rhett's going to show us what he did on the right side. So cotangent is cosine over sine. Okay, go ahead and multiply those together. Okay. Cosine squared is 1 minus sine squared. There you go. And actually, if you go ahead and do a side-by-side comparison, you notice anything? Okay. What Red is writing now, isn't that just the exact reverse of what we just saw? Yeah. But it still works. See, there's your cosecant, and there's your sine, because one pair cancels. There you go. Perfect. Does that help? Okay. In fact, is everybody okay how he went from 1 minus sine squared over sine to the two different fractions? Normally, we're accustomed to pulling fractions together with a common denominator, but remember, it is reversible. You can separate those. Perfect. Perfect, perfect. Nice. Okay, I believe we have one left. All right. Secant squared, cosecant squared equals secant squared plus cosecant squared. Okay, this one I'm going to go ahead and give you 5 minutes. We're going to do the same thing, at the end of which we'll get another person up here to go ahead and help us out. Okay. So what are people already thinking? How many people are going to go left side? Okay, so a few hands going up. Anybody going right? Okay, so not everybody's hands are going up, so maybe we're undecided yet. Going in the middle side. There we go. All right. Okay, now remember, if you get stuck, okay, get to know your new villain buddies. Ask me a question. Again, this is another one. I saw a really nice method last class period. Pim Breitweiser. Anybody know her? She came up with a really good method for solving this that actually is really quick. So let's see if anybody comes up with that same idea. Anybody stuck? Okay, 2 minutes. Okay, that's been 5 minutes. Okay, do I have a volunteer or do I just need to use the random number generator? Okay, let's see who our lucky contestant is. 2. All right, Alyssa. So I'll come up and do it. All right. Okay, so Alyssa, did you go with the left or the right? Left, okay. Okay, now remember, if you get stuck, we're going to help you out. Okay, did you have an idea?
No.
No? Guys, what do you think? Help her out. Okay, Flaws, what do you think? Okay, so you're wanting to start on the right side? Okay. Alyssa, is it okay if we start on the right?
Yes, it would be right side.
There's an eraser on the pin.
Oh, on the back?
There you go. Okay, so Fawaz's idea was to go ahead and change secant squared and cosecant squared to its reciprocal. Try putting it back real quick. Yeah, there you go.
Okay.
There we go.
I'm changing it to the reciprocal.
Mm-hmm. Okay, so what is the reciprocal of secant? 1 over cosine, so this would be 1 over cosine squared. Bless you. Oh. Squared, and then our value. What's that?
Wait, never mind.
There you go. Here, let me. Okay. Okay, good. Okay, so now we got two fractions in terms of sine and cosine. What now? Okay, so let's are you saying what Fawaz is saying? Okay. Okay, and that's right. Yeah, we just don't want to forget the square on the other one. There we go. That one we had to multiply by sine squared. And then this one we're multiplying by.
What? I don't know what I'm doing. Hold on.
No, you're right. You're right.
I feel like I'm putting a weird though.
Okay, and then x. And then what do we need right here? There we go. Okay. So what we've done, she multiplied the left fraction by sine squared over sine squared. She multiplied the right one by cosine squared over cosine squared. So now they have the same denominator. We can pull those together. Mm-hmm. So it's going to be just one big fraction now. What's your denominator?
And we're just writing that all again, just
Yeah, but you only have to write once. So cosine squared, yes. Okay. And then let's go ahead and draw our line right above it. And what would the numerator look like if we're combining the two different ones? Well, now be careful. Remember, like in the first one, what's 1 times sine of squared?
oh, is that
Oh, 1 times sine squared is just. Okay, here, Christian. Sine squared.
oh, okay.
Okay.
Sorry, I'm done.
No. So that's sine squared
Plus cos squared.
plus cosine squared. There you go. And then remember, we're looking for secant squared, or we start on this, sorry, secant squared times cosecant squared. And actually, now you do have a Pythagorean identity. What is sine squared plus cosine squared? It is 1. There you go. All right. And then that's 1 over cosine squared times sine squared. Okay. And what's the reciprocal of 1 over cosine squared? Secant squared. 1 over sine squared is cosecant squared, which is exactly what we needed. Okay, good. Good job. All right. Thank you, folks. Don't forget the quiz is tomorrow. Those extra problems are on the website. I will see you then.